Hello everyone, welcome to another video of class 9 advanced mathematics, and today we are going to continue with chapter 7. So we are done up to theorem 3. Today we are going to continue with theorem 4, and what theorem 4 says is that the medians of a triangle are concurrent. Now concurrent means they meet at the same point. So we have to prove this, and for this we have this diagram. So what we have done in this diagram is that we have drawn a triangle ABC. We have taken BE as the median of AC. Median means a line that joins the vertex to the midpoint of its opposite side. I hope that is known to you. So we have BE as the median of AC. We have CF as the median of AB, and they meet at G. So what we have done is we have connected AG and extended it to D. We are not saying, or we are not assuming that AD is the median. No, we have to prove this. So we have taken BE as the median, CF as the median, which meet at point G. We join AG, extend it to D. First step. Then what we do, we have this BE line. From C, we draw a line CK in such a way that BE and CK are parallel. Okay. So since they become parallel, and we extend AD up to K, so they meet here. Okay. So here CK and BE are parallel, and we join BK. So that is our construction, the whole diagram that we have drawn here. So we are going to write about this here. So let BE and CF be the medians on AC and AB respectively. Okay, so these two are the medians. Then what we have, AG, okay, medians respectively, which intersect at G. So they are intersecting at the point G. Now AG is joined and extended to D. That is the all over the triangle. Now this BK, CK and DK are the constructions. So we are going to go for first we have to write to prove. So we have to prove that AD is the median on BC. We have to prove that AD is the median of BC. Okay, so that's what we have to prove, and for this the construction that we are doing, the construction is that CK parallel to BE is drawn, AD is extended to K, and BK is joined. Okay, so we have CK and BE parallel, AD has been extended up to K, and BK has been joined. So now we start the proof. So what do we do here in the proof is, if you look carefully, here we have BE and CK as parallel lines. That means this GE and CK are also parallel, obviously. So if you take the triangle this ACK, the right hand side of the whole figure, this right hand side triangle ACK, here we have E as the midpoint of AC because BE is the median. So as BE is the median, E will be the midpoint of AC first. Then we have GE and KC as parallel lines. So since GE and KC are parallel, E is the midpoint of AC, obviously G will be the midpoint of AK. It's like this, it goes like this. Suppose you have a triangle, you have a line in the middle which is parallel to the base. If this is the midpoint of this line, and if this line is parallel to this, then this will also be the midpoint of this line. You have studied about this theorem earlier in previous classes. I hope you remember that. Okay, it also goes in the opposite way. Suppose you have a triangle and you join the midpoints, then this line will automatically become the parallel of the base. So I hope you remember this theorem or this concept. So here, as we have E as the midpoint of AC and GE parallel to KC, therefore in triangle ACK, G will be the midpoint of AK. So we will write about this. So since GE is parallel to CK, this is by construction, and E is the midpoint of AC, therefore G is the midpoint of AK. So now we have G as the midpoint of AK, first step, and also we have obviously, and also BG and CK will be parallel, and BG parallel to CK, which is very we have done in the construction, we have done this parallel to BE. So if BE is parallel to CK, then obviously BG will also be parallel to CK. So this is our first part. Next, what we will do, now what we will look into, now we will look into ABK, the left hand side of the diagram. In triangle ABK, F and G are the midpoints. See, here I have told you G is the midpoint of AK. So G is the midpoint of AK, and since CF is the median, so F becomes the midpoint of AB. So now we have F and G as the midpoints of these two sides. That means FG will be parallel to BK. If FG is parallel to BK, then obviously FG has been extended to C. So GC also becomes parallel to BK. So now we have GC and BK parallel as well. So that's what we will write here. What we will write here is, in triangle ABK, as F and G are the midpoints of AB and AK respectively, therefore FG will be parallel to BK. That is, or I can write, which implies, since FG is parallel to BK, obviously GC will obviously be parallel to BK. Okay, now look into this from 1 and 2. BG parallel to CK, BG is parallel to CK, and GC is parallel to BK. That means this structure become BKCG or BGCK. This thing becomes a parallelogram because the opposite sides are parallel to each other. BG parallel to CK and GC parallel to BK. So from 1 and 2, BGCK is a parallelogram. Now we know that the diagonals of a parallelogram bisect each other. So since diagonals of a parallelogram bisect each other, therefore that means D will be the midpoint of both these lines. GK and BC are the diagonals of the parallelogram BGCK, and in this parallelogram BC and GK are the diagonals, and I said that the diagonals will bisect each other. That means GK and BC will have D as the midpoint. Bisect means it will be the midpoint of that line. So that means D is the midpoint of BC. Therefore D is the midpoint of BC. If D is the midpoint of BC, that means AD is the median. So if I can rub this part, suppose, so I will continue from here. I will write here now that therefore AD is the median of BC, and that's what we had to prove. So hence proved. So as AD has become the median, therefore it shows that BE and CF, which were previously the medians, and AD, which is the median now, we have proved it as the median, that all of these intersect at this point G. That means the three medians are concurrent. All the three medians are intersecting at the same point, and this common point where all the three medians meet is called the centroid. It is called the centroid, the point where all the three medians of a triangle meet. So that is how we prove theorem 4. Very easy. You just have to prove this as the parallelogram. Once you can prove this as the parallelogram, it is just a matter of a few lines that BC and GK will obviously be bisecting each other. That means D will be the midpoint of BC. If D is the midpoint of BC, then that means AD is the median on BC, and if AD is the median on BC, that means all the three diagonals are medians are meeting at point G. So we have proved theorem 4, where we have proved that all the medians of a triangle are concurrent, and that point of intersection is called the centroid. So I hope you've understood this one. In the next video, we're going to start with the exercise 7. So make sure the theorems are clear. I gave you a few sums to solve as well. Try to solve those. It will help you in these are all from the examples of the book. So if you have any problem, you can go, I have given you the solutions from the book itself, so you can check out the examples and then we'll start off with the exercise. So thank you everyone for watching, and until next time, cheers.